Hi and welcome back. So continuing our singly linked list, in this video we are going to see that how to perform the deletion of node in the case of a singly linked list. Okay, so this is the last video on the singly linked list part, and from the next tutorial we'll see that what is a doubly linked list and introduce ourselves. Okay, so in this video we are going to discuss basically the deletion of node. So let's start here. So totally there are three cases of the deletion, right? So first is the deletion at the beginning, second is the deletion at the end, and third is the deletion after a given node. Okay, so all these three scenarios we will be discussing, and then finally we will be writing a single code to perform all these three deletion operations. Okay, so you can correlate this deletion operation also with the insertion of a node, right? In the case of insertion also we have total of three cases, right? Insertion at the beginning, insertion at the end, and insertion after a given node. Okay, so you can correlate this part also with the insertion. Again, in this case of deletion of node, again we need to make some changes in the links, and that's it. You will be done with the deletion of node also, right? So let's just quickly look at what are the changes that we need to make in the links, right? Okay, so let's see here. So as you can see, these are the three cases which are deletion at the start, at the end, and after a node. Okay, or in between the node. Okay, and also we need to traverse the linked list for deletion purpose, as similar to the insertion case also. So if you want to delete some node, then you have to reach at that node first, right? So how are you going to reach that node? With the help of traversal of the linked list. Okay, and we know that how to do the traversal from the previous tutorial videos. Okay, so now let's focus and figure out that what are the changes in the links that we need to make to understand it. Okay, so taking the first scenario, it is saying that deletion at the start. Again, we just need to remove this link, because at the starting head was pointing to this first node. If we want to delete this node, then this means that head should be pointing to this node, because after deletion of this node, this will become the first node of the linked list, and hence the head should be pointing to this node. So what are the links that we need to change? First link is this, and second link is this also, right? Okay, now let's now discuss that how to do the deletion at the end. So in the case of single linked list, if you want to delete the node, then in that case what we need two pointers. Without using two pointers you cannot delete this node, right? Okay, so here I am using two pointers. First is previous, second is current, right? So current pointer is the pointer which will pointing to the current node of the linked list, and previous is the pointer which will be pointing to the just before the node, just before the current node, right? Okay, so for this what we are going to do is that let's see, if we want to delete this node, then we just need to make this part, right? That means we just need to make star previous dot next equal to null, then this node will be automatically deleted. Okay, this is what we need to do, right? On to the third part, which is deletion of node in between. So let's say you want to delete the node with value 6, right? So again we need two pointers. One is current, second is previous, right? And the first we'll go on to the element which needs to be deleted using the current pointer. Okay, and automatically the previous pointer will be pointing to the node just before the 6, that is 5, right? So what are the changes in the links we need to make? Again, we need to remove this link, we need to remove this link. Okay, so instead of removing this link, if you make this link, then this task will be automatically done. Okay, so to make this link, what we need to do is that we need to just specify star previous dot next. That means this block is going to hold the address of this, right? And how are you going to get the address of node 7 is by doing star current dot next, right? So this block has the address of 7, hence if we do star current dot next, then we'll get the address of the block 7, right? Okay, so these are the only three cases for deletion of node. I hope you have understood it. Okay, so now we'll go to the Visual Studio IDE and write the code quickly. So let's move on to the Visual Studio IDE. Okay, so here I have written the as usual code to create the linked list. As you can see, this is the function to create the list, and next this is the function to print the list. Okay, and here I am taking the input, as how many elements you want to enter into the linked list, and then using the for loop to create the linked list. Okay, this stuff we have discussed in the previous tutorials. So as of now we have discussed everything about the single linked list, and this is the last part to do. Right, here is the total scenario for the deletion operation. So what I have done till now is that I have used the cout to pop up some messages like here is the start of the deletion operation. Okay, and I am using the for loop to make sure that I can use multiple deletion operations, right? And inside that I am taking one element as an input, and that element is which we need to delete, right? And then again, so here I'm going to write, so for that the return type of the deletion delete function will be of course the struct node star, because there may be this scenario where we need to delete the first node of the linked list, and in that case the value of the head will be changed, and hence we need to update the value after each deletion operation, right? And inside that I'm going to pass the head and the element, right? Okay, so this is enough. Before that, if you do note here that I made this for loop as an infinite loop because I want to perform as much deletion operation as I want. So to exit this loop, I'm going to add one condition that if you enter the element as -1, then I will came to know that now I want to over the deletion operation, right? Okay, so then I'm going to do break from here, right? Okay, now let's just quickly define the function delete element. Okay, so we are going to define this function delete element. So defining the function to delete will be the struct node star, right? Okay, so writing the function here, this is delete element, and inside that I am taking the head of the linked list as input and then the element as input that needs to be deleted, right? So first we are going to perform the search operation, right? So in that case, let's first considering the boundary cases here. So first boundary case may be that we need to say we need to delete the first element of the linked list. So for that the condition needs that we need to check is that if star head dot data is equals to element, then in that case, so this is the case of linked list. Okay, so in that case what we need to do, we just need to do head is equals to, right? So head is equals to star head dot next, right? Okay, and another will be that if head is equals to null, then oops, yeah, so head is equals to null, then we just need to return null, right? Okay, okay, fine. And okay, so this was the case where I need to delete the first element. Now coming to the case where we need to either delete the element which is present between the two nodes, or we need to delete the element which is at the end, right? So for that I'm going to write a single piece of code. So let's say I am taking a temporary pointer let's say current, as I have discussed in the presentation, and this is pointing to head, and another one as let's say previous, that will be pointing to null right now. Okay, now I am going to use the while loop at the end. Okay, so just focus on the condition which I am going to write. Okay, so the condition will be while current is not equals to null. Okay, that means once I reach at the end of the linked list, then I will be able to find that element which needs to be deleted. If not, then that element does not exist, right? Okay, for that I can generate another pop-up message. Okay, so now coming back here inside the while loop, so we need to first check at every stage, right? That check whether the data of the current pointer or the current node is equal to element or not. If it is equal to element, that means we have find the element which needs to be deleted. So this is the change in link that we need to make, right? So that means the previous pointer address part should be assigned to the address as start current dot next. By doing this, you will be able to delete the element which is pointing to which the current is pointing, right? Else if this is not equal to data, that means the current is current dot data is not equals to element, then in that case we have not reached the element which needs to be deleted, so we just need to go on traversing until we finish off the linked list, right? So for that I'm going to first update my previous pointer, okay, and then I'm going to update my current pointer as star current dot next, right? Okay, now by doing this we will be able to delete the element for the both the two cases, which is at the end and after the given node. Now let's suppose that what if the element is not present, then I will check here that uh, if this is equals to null, this means that the element is not present, right? Element is not present, that's it. And I will return from here, right? Okay, fine. And do note that here once I find the element and once I completed the deletion operation, then I can break that loop. Okay, now let's just save the code and we'll just compile it once again. Let's see the compilation part. So it has some okay, so error here. Let's see that what is the error. Okay, so here I have made this should be V. Now let's just save and compile it once again. So you can see it has compiled successfully. Now I will be creating the node. Okay, so here you can see it is saying enter the value of the total number of nodes. Let's say I want to create a linked list of size 5, which consists 5 nodes, and the nodes values will be like this: 1 2 3 4 5. So you can see the 1 2 3 4 5 linked list has been printed. That means we are going in the right direction. And now let's now it is saying that the deletion operation has been started, so enter the element that needs to be deleted. So in this I will be entering 3 test cases. So first test case will test the condition, that is to delete the first node of the linked list or deletion at the beginning. So let's perform the deletion at the beginning by entering the 1. So you can see once I enter the 1 has been deleted and the updated linked list has been printed out. Now let's just move on to the second case, which is a deletion after the given node. So let's say I want to delete 4. You can see the 4 has been deleted and the updated linked list 235 again printed has been printed, right? And just quickly we'll go on to the final call, which is deletion at the end. I will put this and you can see the 2 3 has been printed, and I will exit from this by entering -1. Okay, so we have successfully completed this part. Now let's just quickly revise what we have done, right? Okay, so let's just quickly revise. So we have called that function. So we have used the for loop to perform all the deletion operation or to perform multiple operation on a single linked list, and for each iteration I am going to delete the element, and this is the function to delete the element. After each deletion I'm going to print the updated list, right? So head, the return type of the function will be struct node star, because there may be this scenario where we need to delete the first node of the linked list. In that case the head will be changed, right? So we need to keep update of the head for each iteration or for each deletion purpose. Okay, so coming on here quickly. So first here I have checked that if head is equals to null, that means if the linked list is empty, then in that case we have to just return null. Then I have checked here the condition, which is saying that if you want to perform the deletion at the beginning, then this condition handles the deletion at the beginning. And for the deletion for the other two cases I have used these 2 pointers, which are current and previous, and finally I have used the while loop, right? And the condition for the while loop is check whether current is not equals to null. Okay, and for the each iteration of the while loop I'm going to check whether the data for the current is equal to element or not. If it is equal to element, then you just make this changing, right? And you break from the while loop. If it is not, then we need to traverse the linked list by doing this previous equals to current and current is equals to star current dot next. And I am checking here that what if the current becomes null? That means what if the element is not present? Then this pop-up message will be printed on your screen, right? Okay, so that's it for this video. So I hope you have understood the deletion of the single linked list. In the next video, we will be talking about the double linked list in detail. I hope you have understood it. So please like, share, and subscribe the channel. Please support the channel, and I hope you understood it completely. So let's just move from here, and I will see you next time.